Hi guys, so today we're going to talk about binary ionic compounds. So last time we talked about how we have our ions with different charges, and those charges are actually going to drive things to bond together. So a binary ionic compound is when we have two different elements bonded together due to the formation of an ion. So my example here is I might have a sodium ion and a chlorine ion. A sodium ion typically has one valence electron, so it's desperately trying to get rid of that just one electron, because if it does, then it's going to have that stable noble gas configuration. On the opposite side of that, we have chlorine. So chlorine has 7 valence electrons, so it's just one step away from gaining that noble gas configuration. So sodium wants to give up that electron, chlorine wants to take it in. So what happens is sodium and chlorine, they'll bond together so that they are both satisfied. So that's how we're going to get that bond. So because of this, and we know that the left side of our periodic table, so the middles are typically cations, which are positive, and the right side of the periodic table is typically anions, so our nonmetals are typically negatively charged. Then we know ionic compounds are typically going to occur between a metal and a nonmetal. So you'll want to put that in that space, metal and nonmetal. So how are we going to write binary ionic compounds? There's a specific way that we like to write our formulas. So first thing you know how to do is write the symbol for the ions side by side with their respective charges. We just do this because it's easier to visualize how we're writing it if we write out everything with their charges. Just keep in mind that the cation will always go first. So your plus charge will always be first for everything when we're writing formulas. Next thing you're going to do is cross over the charges, so just the numbers, so that the numbers switch. So I'm going to pair the anion charge with the cation and the cation charge with the anion. It's kind of confusing, but just go with it for now. So these are going to be your subscripts. And then lastly, you'll have to check to make sure the subscripts are at their simplest form. So you make sure you can't do any common denominator canceling. So this is a visual to show what we're talking about. Say we had lithium, which has a 1+ charge, and we had oxygen, which has a 2- charge. What I need to do is take this 1 and switch it so that it's the subscript of oxygen. I need to take the 2 and make it the subscript of lithium. So we're crossing things over. Now, the reason why we do this is because we have to create a neutral atom. Everything's all about being neutral and everything's about being stable. So my example here is, say I was trying to do chlorine and magnesium. So I was trying to form a bond between those two. What would happen if I just had one chlorine and one magnesium bonded together? If I have a 2+ and this is a minus, if these two were just bonded together, we would still have a positive charge. We would still be creating an ion. So what we do is we add 2 chlorines then, because I can say, okay, these 2 negatives are going to cancel out my 2 positive. That way everything's proportional and neutral. So that's why you would end up with MgCl2. So we can see that whatever our positive charge here is, it's going to be what we have to do for the anion subscript. And then it kind of goes vice versa. So what we have for the negative charge, which is just 1 in this case, has to go with our cation. Okay, so let's try an example. We want to write the ionic compound formulas for beryllium 2+ and chlorine -. So remember, if we have a beryllium 2+ and we have a chlorine -, if I was just to leave it like that, it's now not neutral, right? We would actually still end up with like a +1 for the overall charge. So we needed to add that second chlorine there. So if I have a 2 plus and then 2Cl, then it ends up being neutral. So that's why when we're doing this, if we have Be2 plus and Cl minus, I'm going to copy it down like this, and then I will take the numbers and I'll cross them. So this one is going here. This one is crossed over to this side. So we end up with BeCl2. Okay, so try the second one. The second one is asking you to write the ionic compound formula for calcium, which has a 2 plus charge, and oxygen, which has a 2 minus charge. So just try that one really quickly on your own, and we'll talk about it after. Okay, so we've got calcium 2 plus and oxygen 2 minus. So we have Ca2 plus, we have O2 minus. So cation will always go first. So CaO. So now all we have to do is do our cross. So we have 2 here. We have 2 here. Now that last step is saying check the subscripts to make sure the numbers can't be simplified. Right here, that shows me that these can definitely be simplified. With our formulas, scientists really do not like to write numbers. So if we can say, you know, let's reduce this so that maybe our common denominators are canceled out, then they'll do it. So if you have a common denominator, say you had, this isn't something that would happen, but say you had Ca2O4, say you had something like that, you would find the common denominator and reduce. So it'd be like CaO2 when you reduced it. Okay, so we have one more question. Write the ionic compound formulas for lithium and nitrogen. I'm not going to do this one on the video. This one you'll have to find the charges for each. So find the charge for lithium and then find the charge for nitrogen and then write the formula. Okay, so once you're done with that, I would go and take the assessment that is on Schoology, and then you should be good.